This is a review for test 1. Please make sure you read all of the directions. They are very important. So for question number 1, we want to find an angle that is coterminal with a given angle. The directions say that the angle must be between 0 and 360. So what we will do is we will add multiples of 360 onto negative 1409 until we reach something between 0 and 360. So if you were to add 4 copies of 360, which is, 720 times 2, 1440, now we've reached 31 degrees. And since 31 degrees is between 0 and 360, here is our coterminal angle between 0 and 360. And so you see right here that the answer is 31 degrees. For the next question, we have a 25-meter flagpole casting a shadow that's 30 meters long, and we need to determine the shadow for a tree that is 45 meters high. This is one of the problems where you are required to show your work and upload your work. So we want to make sure that we draw diagrams and completely label them and then use a proportion. That would be the work that you would need to provide to me to get full credit for this problem. Remember that your Blackboard score is not your final score. Every single one of the automatic graded problems can be adjusted up, but also for the ones where you are required to show your work, I can adjust the values down based on your work. So let me add all the labels to this diagram and then show you the required proportion. So pay attention to 3 things I've done. 1, I've added the values that are given to us. Here's my flagpole, here's my tree. 2nd, I have defined a variable, and that variable is defined by labeling the diagram. This is the unknown, it's the shadow length. Okay? Thirdly, the angles. Now, first of all, we have a tree and a flagpole that are at a right angle. This is a reasonable assumption for this problem. But the second thing is that we need to have another congruent angle. And because this is the same time of day, that means that the angle of elevation to the sun would be the same for both the flagpole and the tree. This second angle of congruence is really important because now we're allowed to use the angle-angle similarity postulate from geometry. So having our fully labeled diagram, we now set up a proportion that 25 is to 30 as 45 is to x. And this is the extent to your work. After this, you don't have to show any further work. You can use your calculator to arrive at the answer. So if you cross multiply, you will reach the answer that x is equal to 54, and so you put your answer right here. But remember, you don't just give me an answer for question 2, you also will be uploading your work. And you can find out which problems you need to upload from the directions. Questions 2, 7, 8, and 20 require work, and your score will be adjusted accordingly, and that's why this one is worth 6 points and not a mere 2 or 3 points. Question number 3. Given that the point 12,5 is on the terminal side of angle theta, find the exact value of the 6 trig functions. Okay, I apologize, but I'm going to change question 3. The 12,5 was a first quadrant problem, which would not have been very interesting because all of your values would have been positive. So instead, I want to make sure that I get out of the first quadrant. So the example I'm going to show for question 3 is actually going to give me a 4th quadrant point. So I have drawn a diagram here for question 3. I have put my point 4, -3 down in the 4th quadrant where it belongs. And here is the initial side, here is theta, here is my terminal side. So in order to determine the sine, cosine, tangent, all of the functions, I'm going to use a reference triangle. And that reference triangle is formed by taking this point and dropping a perpendicular to the x-axis, and then I'm going to label the sides of the triangle. So this is 4 to the right and 3 down. So whereas normally you wouldn't label a triangle's side length -3, in this case this would be an appropriate thing to do to remind you that you are going down 3. So whether you put positive 3 or negative 3, at some point you need to make sure that you understand that any value using that 3 is going to be negative. And the good thing about the values that are provided for you for question 3 is that they are Pythagorean triples, which means that you should have no trouble getting straight to the hypotenuse. Had it been a 5-12 triangle, your hypotenuse would be 13. In this case, we have a 3, 4, 5. Here's your Pythagorean triple. Now for sine, cosine, and tangent, remember each of these is going to be a ratio. So sine of theta is y over r, which is going to be negative 3 over 5. Cosine of theta is x over r, which is 4 over 5. The tangent of theta is y over x, which is negative 3 over 4. Then to get each of the reciprocal functions, you just flip all of these over. So the cosecant of theta is going to be the reciprocal of sine, so negative 5 over 3. The secant of theta is the reciprocal of cosine, so 5 over 4. And the tangent of theta is the reciprocal, the cotangent is the reciprocal of tangent, so that's negative 4 over 3. The biggest problem that I see students run into here is that they get the signs wrong. Some of them are positive when they're supposed to be negative, or they put their values as negative when they're supposed to be positive. So pay attention to that. This is a fourth quadrant angle. In the fourth quadrant, you should expect to see that sine and its reciprocal are negative, as well as tangent and its reciprocal. Now this one right here is a calculator problem. The first thing you're going to want to make sure you do is that you recognize that the mode of the calculator is going to need to be in degrees. And you can tell that the mode is going to need to be in degrees because this problem is in degrees. The second thing you're going to need to do is you're going to need to type this value into the calculator. And let me show you how I would type it. Okay, so this is what you're going to type into your calculator. Cosine of 204, that's your 204 degrees, plus 31 over 60, this converts 31 minutes to degrees, plus 52 seconds gets converted as 52 over 3600 because there are 3600 seconds in a degree. So you just type that all into your calculator at once and you should get your output. Here is your answer. Round to the nearest thousandths. This one happens to be rounded to a hundredths place, and that's because the number that follows it is 0 if you round it to the nearest thousandths. But just make sure that you go out 3 digits round to the nearest thousandths. If this problem had any other number besides 0, you would have seen it show up right here. Okay, now for this next problem, it says, consider the right triangle where A is 7, beta is 60, find an approximate value accurate up to 3 or more decimals of each of the following. So this is a basic SOHCAHTOA problem. So let me show you this on the board. So for this problem, first of all, to find alpha, we just use the triangle sum theorem that says that the sum of the angles must equal 180. So subtract your 90, subtract your 60, and alpha is going to be 30 degrees. Now for B and C, we're going to set up sine ratios and a cosine and also a tangent. So the reason we're going to use a cosine to find C is because we know the adjacent side and we're looking for the hypotenuse. And you could base this off alpha or beta, it doesn't matter. In this case, because beta is given to us, I'm going to do everything in terms of beta. So the cosine of 60 degrees is adjacent over hypotenuse, 7 over C. So when you cross multiply, what you end up with is that C is equal to 7 over the cosine of 60 degrees. And you can type that in the calculator. I think that's going to be 14. Yeah, it just occurred to me that the cosine of 60 is 1/2, and therefore 7 divided by 1/2 is 14. So in this one, Technically, you don't need a calculator for this, but still, a calculator is fast. Next, to get b, we're going to use the tangent of 60. The tangent is opposite over adjacent. B is opposite and A is adjacent. So now this one says that B is equal to 7 times the tangent of 60, and I am going to type that one into the calculator. And when I typed it in, I ended up with this decimal. I rounded to the nearest thousandths so that I would at least go 3 decimal places. You can see the values here. My open math problem went ahead and gave you a long string. Just wherever you cut it off, make sure that you round appropriately. I will be checking everyone's answers though. Next, question number 6. We are given A and B, and we need to figure out C using the Pythagorean theorem, and then capital A and B using some inverse function. So for this problem, first of all, we want to be able to find the hypotenuse. You can use Pythagorean theorem, or you can also note that because the side lengths are in ratio 6 to 8, this will be a 3, 4, 5 triangle ratio, which would be a 6, 8, 10. Pythagorean theorem will get you the same result. So next, in order to find angle A or angle B, it doesn't matter, I'll just pick angle A, I need to use a ratio. So tangent of A, and you can pick to use sine, cosine, or tangent. In this case, I'm just picking tangent because I was given 6 and 8 to start with. The tangent of A is opposite over adjacent, so that would be 6 over 8. So that means that angle A is equal to the tan inverse of 6 over 8. So I'm going to type that into the calculator. Make sure you are in degree mode. And this is approximately 36.869896765. So to get the other angle, you just subtract this value from 90, and B then is roughly 53.13, etc. So here are the answers right here. You only need to give to at least one decimal place. So you could round this one to 53.1, and this one would round to 36.9. All right, next question is question number 7. Both questions 7 and 8 require you to upload your work. They are worth 8 and 10 points respectively, so these are big problems. So for question 7, we have a radio tower located 300 feet from a building. From a window in the building, a person determines that the angle of elevation to the top is 24 degrees and the angle of depression to the bottom is 22. How tall is the tower? So the first thing you need to do is give a fully labeled diagram. So you do not need to have an elaborate drawing. Here's my building, here's my window. You just need to have this point right here. The horizon line will be perpendicular to the tower, so we get to put a right angle here. Make sure your diagram includes the right angle. There is a 300-foot distance between the building and the tower. That means that this side right here is also 300 feet. The angle of elevation to the top is 24 degrees. The angle of depression is 22 degrees. This does not need to be drawn to scale. Just make sure you label it appropriately. Now, what I would recommend is that you pick 2 variables. For instance, this one could be A and this one can be B. So B represents this chunk and A is this segment up here. Once you get A and B, you can add them together and get the whole height. So this is a simple SOHCAHTOA problem. Let's set up the ratios next. Here we are looking at a tangent. Tangent of 24 degrees is opposite over adjacent. Tangent of 22 degrees is opposite over adjacent. And so the height of the building is going to be A plus B, and A is equal to 300 times the tangent of 24, and B is equal to 300 times the tangent of 22. So I'm going to type all of that into my calculator. And I get a value that is 254.776, etc. This is feet. Make sure that sounds reasonable. This is a reasonable height. Now, this problem does not indicate where you should be rounding to, so I would just go out a few decimal places and stop. In this case, maybe go out 3. Ultimately, I'm going to look for at least the nearest foot, so you should not give me anything worse than 255, but ideally you will go out a few decimal places. Okay, so next for question number 8, we have a navigation problem. We have from A to B, the private plane flies 2 hours at 110 miles per hour on a bearing of 27 degrees. It turns at point B, continues another 1.6 hours at the same speed, but on a bearing of 117 degrees to point C. So let's start by making a diagram. So first, when I drew my diagram, I started with a point A. I drew a north line. Since I have a bearing of 27 degrees, I just moved a little bit to the right here, and I put out a length of B. Now, a length to B. Now, once you get to B, you need another north line so that you can find 117 degrees. Remember that this bearing is going to start at due north and move clockwise. And now my next segment, I drew this one a little shorter than the previous one because this is 2 hours and this is 1.6 hours. Now, next I'm going to put distance labels here. So next in green, I've added some lengths here. So since the first part of the journey is 2 hours at 110 miles per hour, 2 times 110 is 220. The next part of the journey is 1.6 hours at 110 miles per hour, and multiply those two numbers together and you get 176. Now let's look at the questions again. The first one is, at the end of this time, how far is the plane from its starting point? And the second question is, on what bearing from due north is the plane from its original location? First question is asking us to find the length from A to C. So we could just call this one, I should call it B because it's opposite angle B. That would be smart. So what we need to do is try to figure out this length right here. Now, given the fact that we have two north lines here, and these north lines are parallel lines cut by a transversal, these two angles here are called same side interior angles, and they have to add up to 180 degrees. They have to be supplementary. So if we were to subtract 270 from 180, we end up with 153 degrees. So this angle right here is 153. Now add together 153 and 117, and you get 270 degrees, which means that the angle right here is going to be a right angle. Make sure your diagram includes this kind of labeling so that I know you're not just guessing that this is a right angle, but in fact you deduced for yourself that you do in fact have a right angle based off the label right here. Okay, so now that I know I have a right triangle, now I'm going to use the Pythagorean theorem to figure out what B is. And that would be adequate work to find B. You can type this into your calculator now. B is approximately 281.737 miles. Right, now let's look at the next part of the question. The next part of the question is, on what bearing from due north is the plane from its original location? So what we want to do is determine the angle that starts at due north here and then goes all the way to the side B. So in order to get that, we have a missing angle right here, which I am going to call alpha. And once I find alpha, I can add 27 degrees to alpha, and then this entire angle from due north to the green line here will be the bearing of the point C from point A. So how do we do that? Well, to find alpha, and alpha right now is only representing this angle in the triangle, alpha is going to be found using a SOHCAHTOA ratio, right? So we can use tangent, for instance. That way we're not using a rounded value. The tangent of alpha is equal to the opposite over the adjacent. So alpha is then tan inverse of 176 over 220. Which is approximately 38 point, it's going to round up to 660. So that's about 38.660. By the way, that is rounding up. And then if you add 27 to that, you'll get your full bearing. Now, MyOpenMath, when it puts the correct answer out here, is not necessarily putting the correct answer that they are looking for, but the answer that they are going to be using to judge your answer. So notice here that really you need to round each answer to 3 decimal places. So this value right here is the 38.660, which was originally 38.6598. Added on to 27 degrees. But you see, if you try to round up, this 8 forces this 9 up to a 10, which would make this 5 a 6. So this answer turns out to be 65.660. So pay attention to your rounding. If you do make rounding errors, it's going to cost you a very small amount, so it's not the most important thing about this class. Question 9, convert 300 degrees 18 minutes to radians. Okay, so the way we convert this to radians is first we want to think of this as a mixed number. So this is 318/60ths of a degree as a mixed number. Now we're going to turn it into an improper fraction, and to do that we multiply 60 times 300 and add 18. So this is the same thing as 18,018 over 60 degrees. So first, from degree minutes to a mixed number of degrees to improper fraction of degrees. Now to turn from degrees to radians, you're going to multiply by pi over 180 degrees. And so the degrees then would cancel. So what we're looking for is a fully simplified answer. I can see that the number on the top is divisible by 2. It's also divisible by 3 and probably 9. So I wonder if the whole answer, of course, originally would be divisible by 18. 18,018 divided by 18 simplifies to 1,001 pi, and then that would be 600. So, and that would be your fully simplified answer right there. I just reduced my fraction as much as possible by dividing both the numerator and the denominator by 18. Now again, what I want you to notice is that this is saying give the exact value and use pi. Do you see that the answer here is not an exact value? It's a decimal. This is just the decimal that the calculator will, or that the computer is using to judge your answer, but we are looking for an exact answer fully simplified, so make sure that you include that. For this next problem, this is unit circle information, so you're going to need to you can have your unit circle on the test, it's open notes. So you need to be quick though about getting to each of these values. Now I can do all these in my head, so this is just kind of a little representation of my head. Here is 0 degrees, and this is 0 radians, sorry, same thing. The sign value then would be 0 because that's the y value. Next, negative 4 pi thirds. So negative is going back in this direction, and 4 thirds is 1 1/3. So I'm looking at the point Up here, the cosine value back there is negative 1/2. Next, I'm looking for 5 pi 6. So 5 pi 6 is going to be 5/6 of the way around here. This is going to be sine over cosine. Now, the sine value at this point is only 1/2, and the cosine value is going to be negative root 3 over 2. And if you simplify that complex fraction, you get 1 over negative root 3, and 1 over negative root 3 simplifies further to negative root 3 over 3. Next, secant of negative 3 pi halves. So I'm going to go backwards to get to negative 3 pi halves. So here's 1/2, 2 halves, 3 halves. So I'm looking at the point up here. The cosine value here is 0 because the x value is 0, and the secant is the reciprocal of that, so secant does not exist at this point. You cannot take the reciprocal of 0. Next, cosecant of negative 2 pi thirds. So I need to go negative 2/3 of the way. That's going to put me right here. The sine value at this point is negative root 3 over 2. And I need to take the reciprocal of this sine value so that I can have cosecant. So if I flip that over, 1 over that is going to become 2 over negative root 3, which when you simplify becomes negative 2 root 3 over 3. So you've got to have a good understanding of how to deal with complex fractions and how to rationalize your denominators here. Next, cotangent of 2 pi thirds. 2/3 is going to be right back here at this point. My cosine value is negative 1/2, and my sine value is root 3 over 2. And I need to have cosine over sine in order to get cotangent. Now it turns out that this ratio right here is equal to this ratio right here. So going back to the same value here, this turns out to be negative root 3 over 3. So this part of the test can either be something very fast or very slow, and it will just depend on how much you became acquainted with the unit circle, how comfortable you are. So if you are not super comfortable with the unit circle, then you need to get super comfortable, as I told you before. Go back to that lecture that I posted on the unit circle if that would help. Go find unit circle practice on the internet if you need to, but definitely you're going to want to go through the unit circle, and I would repeat this question in particular. You get 100 versions of this practice test. So if you can go back through this 100 times and just keep repeating question 10 until you can get all of these right in a short amount of time, that would be a good way for you to get through this. Okay, so now with question number 11, we're looking at a graph matching problem. So first we want to identify the fact that our sine function is not shifted to the right or the left, which means we're going to eliminate anything that looks like a cosine function. Next, we can identify the fact that this is a negative sine function, which means the sine function has been flipped upside down. This is a vertical reflection right here of the original sine function, so that would be our answer. This is the original sine function, so it is not our answer. Next question, number 12. We need to graph this function. So first we're going to pay attention to the fact that the amplitude is 4. This is a cosine function that is not shifted to the right or the left. With a b value here of 1/2, that means that the period of this function will be 4 pi. So I like to use this tool right here. It's a little easier, I think, to use. With a regular cosine function is going to start at its peak, and the peak in this case is going to be 4. And then that peak has to drop down a quarter of the way through the cycle. It's going to drop down to 0. Now, since the period is 4 pi, a quarter of the way through the cycle would be at pi. So here is one of the midline points right here. It's not cooperating. Are you not cooperating? Nah. Oh, there it is. Now it's cooperating. Okay, now, so I have a midline point here, and I can come back up here to 4, and there is the cycle. So we have an amplitude of 4. We go down to 0 a fourth of the way through the cycle, drop down to -4 halfway through the cycle, come back up to 0 3/4 of the way through the cycle, and then we have reached one full complete period after 4 pi. Next, question number 13 is going to have me identify whether this is sine or cosine. And since there's no horizontal shift, I can just look at this shape right here and see that it's starting at 0, which would make it a sine graph. So I know it's going to be sine. And next I need to make the observation of the amplitude. This graph actually only goes up to 1, so my amplitude is 1. I'm putting this in here for effect. So now I'm dealing with a sine graph, so I'm going to go ahead and put sine next. And then I'm going to have parentheses. And in my parentheses, I need to have this k value, which is the same as a b value. So to compute this k value here, I'm going to say that since the period going from -14 to 0, that means we have a period of 14. And the period is equal to 2 pi over b, or in this case, the b value is represented by the variable k. So if you solve this equation for k, you end up with k is equal to 2 pi over 14, or pi over 7. So going back to my equation here, I need a pi over 7. So here is my pi over 7, and then I need to have an x in there, and that would be my correct answer. So you do not need to have the 1 out in front. I just put it there because remember that your amplitude could be something other than 1, and I just wanted you to note that whatever your amplitude is for your problem, you will need to include it here at the front. Okay, question number 14, we're going to analyze this equation. This is for 14 and 15. We're doing some basic analysis. The amplitude here is 6. Same thing over here. You can see that the amplitude would be 7. The period is 2 pi over the b value. 2 pi divided by 3 is 2 pi thirds. Over here, the b value is a little more complicated. So you would have to take your 2 pi and divide 2 pi by 7 pi over 6. Remember that dividing by a fraction is the same thing as multiplying by the reciprocal. So if you divide by 7 pi 6, you really end up with 12 over 7, and that's how you determine what the period is for a problem with this kind of complicated number. So they have written it as a decimal, but you need to write it as 12 over 7. Phase shift. This would be a phase shift of pi thirds, and you don't have to say to the right. If you write a positive pi thirds, that indicates that you are moving to the right. Here in this problem, they called it horizontal shift, but I want you to note that phase shift and horizontal shift are the same thing. The only difference is that when you have the phrase phase shift, you don't also have to say to the right or to the left. A positive means to the right, and a negative means to the left. However, when you talk about something in terms of horizontal shift, then you do need to say whether you have it to the right or to the left. You can see here that because this is a subtraction sign, we are moving to the right. And the question is, how far are we moving? Well, we would have to factor this out. Now, when you factor this out, you'll end up with a 7 pi 6 times x minus 2. You can check that this is right by using the distributive property. Notice that 7 pi 6 times 2 becomes 14 pi 6, which reduces to 7 pi thirds. So that means that we have a horizontal shift that is 2 units to the right. As for the midline is based off how far up or down you are shifting. You are shifting up 3. This equation is already started for you, so you do not need to write y equals in your answer. Instead, you just write 3 because the y equals is already provided for you. In this next problem, we need to figure out how to write the equation of this sine graph. I have the point here pi halves 0, which means that my sine graph has shifted to the right by pi halves. I can notice that I have an amplitude of 4. The period goes all the way from -4 to +2 pi. That's one cycle. That would be a period of 6 pi. So noting that I have a period of 6 pi, sorry, that's supposed to be a 6 pi, that I have an amplitude of 4, and that I have a shift to the right of pi halves, then my final answer is going to be 4, that's your amplitude, sine of, and you can write this in a different way. Let me show you an alternative way of writing it. So the number here is 4, but here I have a 1/3 written, and that represents a b value of 1/3 to make the period a full 6 pi. And then I'm shifting to the right by pi halves. This right here is algebraically equivalent to this right here, just 2 different ways of writing it. Okay, now question number 17, I need to sketch the graph of this function. It is a sine graph with a normal period of 2 pi, but it has been shifted to the right pi. So if you shift to the right pi, you're going to be starting right here, and then the graph is going to go down first because it is a vertical reflection of the sine graph. And so I am going to go in 1/4 cycle, which would be pi halves, go all the way down to -2. Now, so what you can see here is that I have a period of 2 pi because I go from -pi to +pi. You can also see that my amplitude is 2. You can see the reflection here, but think about this. If you move sine over by half of a cycle, then that half a cycle shift is going to undo this negative reflection, which is why it looks like a positive sine graph. For number 18, we need to figure out the equation of this one. Here there is no horizontal shift, so first we need to make the observation that this would be a cosine graph. This cosine graph has an amplitude of 6. There is, oh no, not an amplitude of 6, an amplitude of 5. Look for the midline first. This is a shift up problem. So with a shift up problem, or shift down, it could be up or down. In this case, you can see that there's a midline here at +1. So from 1 up to 6 is a distance of 5. Likewise, from 1 down to -4 is a distance of 5, and that's how we get the amplitude of 5. The next thing we want to pay attention to is, in addition to the fact that this is a shift up by 1, is that we have a period change. What is the period of this function? Going from peak to peak, it's a period of -6. So how do we get a period of -6? If the period is 6, then it's equal to 2 pi over the b value. In this case, the b value is represented by k. Solve for k. K is 2 pi over 6, which is pi thirds. So we're looking at an amplitude of 5. Then we have a cosine function. The k value is pi thirds. I used brackets here, but I should have used parentheses. It doesn't matter. It will function the same way. And then I'm shifting up 1. So there's your answer right there. Number 19 is going to be the same type of problem again. This time you can see that you have a sine function and this graph is shifted down 1. And the amplitude is still 5 in this because the distance from -1 to 4 is 5 and the distance from -1 to -6 is 5. the period of this function, I am going from what looks like 3.5 back to negative 10.5. And negative 10.5 to 3.5 is 14. So here, your k value is 2 pi over 14, which reduces to pi over 7. So I have an amplitude of 5. This is a sine graph. Pi sevenths. Shifted down 1. And here it is right there. Now for number 20, the work that is required for number 20, this is the last one you need to upload, is a hand-drawn graph where you're going to include one full period, the y-axis labels and the x-axis labels at each quarter cycle. This comes with a really helpful video, and this guy's video demonstrates exactly what you would need to do for this problem. So rather than me walk through the exact same thing, it would be most efficient if you...
The outside temperature over a day can be modeled as a sinusoidal function.
You can see that he's going to walk through it nice and slowly for you.
Since the period is 24 hours.
And he's actually going to graph it for you too.
Now to graph this, we'll divide it into 4 equal parts. We should also recognize that our graph has been reflected across the x-axis.
All that to say, follow that guy's video. That's going to give you one full period with the y-axis labels, the x-axis labels, everything that you need. This is what you should do. Follow this video. All right, question number 21. To get the period of this function, we take pi, remember, not 2 pi because this is tangent, and divide pi by the b value of 6, and you get pi 6. If you factor out the 6, you get 6 times x plus 5. So this is a 5-unit shift to the left, and that's as simple as that. Now for 22, you got to figure out what the function is. So what I would do first is try to figure out where the asymptotes are. The asymptotes are going to be halfway between 0 and 6. So I would have an asymptote at 3. And then I have another asymptote halfway between 0 and negative 6. So I have another asymptote here at negative 3. And seeing that I go from negative 3 to positive 3, that means that the period of this function is 6. So that means that the value inside the parentheses for tangent, and this is a tangent graph because I am straddling the y-axis, and my tangent orientation is positive, so I have a positive tangent graph. I might need to add a value out in front. But inside, I need to have pi over 6 in order to get a period of 6. So you take pi, you divide it by this value right here, and that will result in a period of 6. My graph is not shifted up or down, but I do have a stretch. If you look, we're going to go for a quarter cycle. A quarter cycle is the 1.5 mark. So we're going to come up here and see how high are we at 1.5. Oh, we're all the way up there at 4. So we actually have a value of 4 out in front of this tangent. It has been stretched vertically. Come on, graph. There we go. 4 tangent pi 6 x. For number 23, the period of secant and cosecant is going to be 2 pi divided by the b value, so we have 2 pi divided by 7. If you factor out the 7, you have 7 times x plus 2. That would mean a shift 2 to the left. And that's as simple as your problem is for number 23. So 23 is a pretty simple problem, just like number 21 is. Number 24, though, we've got to figure out the equation, and figuring out the equation, those can be the tougher problems. So what I would say is, try to figure out, first of all, where the midline is. The lowest point here is -1. The highest point is 3. So halfway between -1 and 3 is 1. So I have a midline up at +1. And now what I'm going to try to do is fill in the blanks of trying to figure out where is the base graph, the graph that connects to this, okay? So there would have to be an asymptote in here somewhere, halfway in between. My graph is going to come up from this point right here, and then it's going to come down partway in between and come down like that. So I can see a bit of where it's at. That's going to give me some clues. What I need to do, in addition to noticing that I'm going to have a shift up by 1, I need to first also look at the amplitude. Since from 1 to 3 I have a distance of 2, I know my amplitude is going to be 2. Next I need to figure out what the period of this function is. This graph right here looks like it's about -1 1/3 all the way up to here, which is like 3 2/3, and that is a total of 6. Sorry, or rather a total of 5. So yeah, you can see here from this it's about -1 1/3 to 3 2/3. So that's not 6, that's 5. So if I have a period of 5, that means that the b value inside the graph will have to be 2 pi over 5 in order to create a period of 5. So here I'm going to next want to figure out, is this sine or cosine? Since the graph does start out by going up and then it comes back down, that is going to be a sine graph. So I'm going to see a 2. Then I'm going to say that the reciprocal of sine is cosecant. So I would have the cosecant. Next, the b value is 2 pi fifths. I have no shift to the right or the left. That would make this a very difficult problem. And then I would be shifting up 1. So let's see how this compares. Take this pencil off. Here we go. 2 cosecant 2 pi fifths x plus 1. Alright, so there you go. And that's all you need. And just make sure that you follow the directions that for 2, 7, 8, and 20, you're going to be showing all your work. So again, that would be the triangles fully labeled for number 2. You've got your tower problem fully labeled. Your navigation problem, of course, you need to show all your work for that one. And then for your temperature problem, this one is a tricky problem. It's worth 10 points. But this is a very excellent video that will walk you through exactly what you need to do for that problem. And for this problem, you need to have a hand-drawn graph. You have 20 minutes after you submit this, when you're taking this test for real. You will submit it through My Open Math, you'll close out RP Now, and then you'll get on Blackboard and you'll have 20 minutes to submit your pictures, your PDF files, just like you do for homework. You're going to do it here. Let me show you where you're going to submit it for the test. Okay, so here in trigonometry, what you'll do is you'll end up going over to Unit 2. And when you get to Unit 2, you'll scroll down. By the way, this is where I post the videos, if you hadn't already figured that out. Scroll down to where it says well, it's going to say test. Hold on one second. Okay, so when you scroll down past this, it will say test 1. This becomes available at 1 o'clock p.m. today, so that you couldn't have seen it. But when you click on test 1, you would upload just like you would for homework. So that's where you're going to go to submit those problems. The directions here you will find are the same directions on My Open Math. To take this test, you need to go over to where it says RP Now for students in the menu. And then once you are in the menu, just like you did for the practice test, you're going to go through the same steps. If you have any questions, please email me.